In this question, we're asked to write the electron configuration for calcium and then draw it as a box diagram. So first, let's write the electron configuration and then we'll convert that into a box diagram. So because of the Aufbau principle, electrons fill from lowest energy levels to the highest energy levels. So when we're doing the 20 electrons in calcium, we need to start in the 1s2 orbital, or excuse me, the 1s orbital. So first, it fills the 1s orbital, 1s2. So now the 1s orbital is full. So now we move to the 2s. 2s, which holds 2 electrons. 2p, which holds 1, 2, 3, 4, 5, 6 electrons. 2p6. Now that's full. So we move to the 3s2. Then to the 3p6, because the p orbital holds 6. And then finally 4s2. And to check our work, we can simply add the superscripted numbers. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, which matches the number of electrons in calcium. So this is the electron configuration of a neutral atom of calcium. Note that you are allowed on an exam, for example, to write this as a noble gas, one period above it. So calcium's in period 4, go to the noble gas in period 3, argon in brackets, and then 4s2. That won't work to solve this problem because we need all the electrons, but that will work in general. So now moving along to drawing this as a box plot, essentially what you want is energy on this axis, so as energy increases. The first orbital we encounter is 1s2, so that's the lowest in energy. So that's the 1s orbital. It holds 2 electrons. One has a spin of plus a half. One has a spin of minus a half. So one up, one down. The next orbital we encounter by energy is the 2s. It has 2 electrons, one up, one down. The next orbital we encounter is the 2p. And the p has 3 orbitals. If you're looking at the quantum numbers, this is ml of minus 1, ml of 0, ml of plus 1. And it's holding 6 electrons. By Hund's rule, the electrons spread out evenly and have the same spin. So up, 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 then down, down, down. In this case, it doesn't matter because it's full, so they're all going to be spin paired. Next, we encounter the 3s, which has 2 electrons in it. Next, the 3p, I should have written that a little bit higher, which has 3 orbitals. There's 3p orbitals. So 3p, up, 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 down, 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 and it has 6 electrons and is full. And then finally, the 4s, which has 2 electrons. So this is the box diagram for the 20 electrons in calcium. These are both representations of the electron configuration of calcium.